Okay, so we're going to take a look at another question from the 2023 HSC Advanced Maths paper. This is question 20. So we are told find all of the values of theta where theta is greater than or equal to 0 degrees and less than or equal to 360 degrees, such that sine of theta minus 60 degrees is equal to the negative square root of 3 on 2. Okay, so this is a standard trig equation. What we could do is we could try and graph this. And this is what I'm going to do straight away. The graphing is going to tell me how many solutions I should expect. So if we draw a little graph of this, this is just the sine function, and it is shifted to the right by 60 degrees. So adding a number shifts it left, subtracting a number shifts it right. So normally the sine function would look like this, but the whole thing needs to be shifted right by 60 degrees. So it's going to start at 60. It's going to complete half of a complete circulation at 240, and then it's going to complete the next part. So we're going to have to add 180 to this. So this value will be 420. Now it will also have a little bit of a curve over here. It won't quite get as far up as the peak though. So this is 1, this is minus 1, this is y, this is x. Now we need this function to be equal to minus root 3 on 2. Alright, well minus root 3 is about 0.4, about 1.4. So this is minus 1.4 on 2, it's about 0.7. So that's going to be somewhere here. This is about minus 0.7. So if we look at this line, from our crude graph, we have 2 or 3 solutions. It's possible that there's a solution at the beginning, but there are definitely 2 solutions over here. The shift is making it a little difficult for us to work out if there is a solution right at the beginning from using a quick graph. Right? So this is just a quick graph to try and gauge how many solutions we want. There's definitely 2 solutions over here, and there might be one at the beginning. So let's go ahead and solve the 2 at the end, and then once we've got the 2 at the end, we'll use information about the graph to tell us if there is in fact one at the beginning. So this is the same as solving for plus root 3 on 2. In a sense, we're using the same scale as if we were solving for plus root 3 on 2. So what we're going to do is we're going to draw our normal sine function unshifted like this, and we're going to have a plus root 3 on 2 up here, and then we're going to find this angle, which I will call alpha. So we have sine of alpha is equal to square root of 3 over 2. Now from our special triangle, this is 90, this is 30, and this is 60. This is 2, 1, root 3. Sine of 60 is root 3 on 2. This implies alpha is 60. Now this is important because this shifted function up here has the same proportionality as the standard sine function. And that means whatever these 2 solutions are, this solution here and this solution here, they will be alpha away from these intersections, right? Because the geometry of the sine wave is exactly the same. We haven't stretched it out or squished it in. So this one will be 60 units away from 240. So this one here has to be 300. And this one has to be 60 units back from 420. So this one has to be 360. Now, because we have 300 and 360 and we know the difference between the solution and the x-intercepts is 60, this tells us that we will actually have another solution directly down here because it's been shifted by 60. So we will have a solution here. It will occur at 0. So when we're told to find all values of theta, we have theta equals 0, we have theta equals 300, and we have theta equals 360. This is all in degrees. These are the 3 solutions to this particular trig equation. And I was able to do this in this particular case just by relating the fundamental geometry of the normal sine function with the sine function that we were given in this question. Right? Once you knew how far the distances were between the intersects and the points, you were able to just add or subtract those distances from the intersections. And this gave us the 3 solutions. So let's talk about the marking. In order to get 1 mark, you have to recognize that the alpha is equal to 60. So you could either do this at the start or at the end, depending on how you're solving this problem. This was done at the end in this case, in my version of the question. You have to identify that there are shifted solutions, so that there are solutions around 240, 300, 360, 420, something along those lines. So this will get you another mark. And then you have to show all of the correct solutions with sufficient working. So this will be the 3 marks for this question. And there's many different ways you can do this type of question. You don't have to use the geometry of the sine waves. It's nice to do that because it always relates the question back to the fundamental sine and cosine waves. That's always a good way to go. It is a little harder because if the function does get stretched or squished or moved around quite a lot, it can become a little bit difficult to relate that to the normal sine function. But in this case, it was not too bad. And this is question 20 from the 2023 Advanced Maths paper.